Okay, boys and girls, as promised, I'm going to do some of these problems out. So if you need the extra explanation, hopefully this will help. I'm not going to do them all. I'll just do a couple from each section. Okay, so for this one, I'll do 19 first. So we're going to distribute. So this is negative 32x plus 20 equals negative 32x minus 26. Now I'll have to add 32x to both sides. These will cancel out, and I'm left with 20 equals negative 26. So this is a false statement. This is not true, which means there is no. Okay, so be very careful. I know when we combine these terms, we get 0x, but remember 0x is the same as 0 times x, which is just 0. So that is no solution. If I do the next one, I'll distribute twice on the left side. I get negative 3x plus 3 plus 8x minus 24 equals, if I combine these terms, I get x plus 7. So if I combine these, I get 5x. If I combine these, I get negative 21 equals x plus 7. Subtract x from both sides. I get 4x. Add 21 to both sides. I get 28. Divide by 4, and I get x equals 7. So that's how you do the first two, just simple solving for x. Okay, so these next set is multiplying binomials. Something you might have seen at the end of Algebra 1, if you remember. But a couple ways to do this. You could do FOIL. I hate FOIL just because it doesn't work if there's more than two terms in each set of parentheses. So the concept is you're distributing one term from one set to each term of the other. There's many ways you can do this. You can think about it as FOIL. You can draw these fancy arrows, or you can put it into an area model, which looks like this. Kind of like a square, a couple boxes here, and then we just play Battleship. So this and this, 3p times 3p, 9p squared. 3 times 3p is 9p. 3p times 2, 6p. And then 3 times 2 is 6. Combine my like terms. 9p squared plus 15p plus 6. That's one way to do it. Or if you want to do it this way with the arrows, 3p times 3p, 9p squared, 3p times 2, 6p, 3 times 3p, 9p, 3 times 2 is 6. Same numbers, same result when I combined my like terms. So whatever way you want to do it, it's okay with me. If thinking of it as FOIL helps you, then that's fine. Just understand that you are distributing terms, and when there's more than two terms, the FOIL concept will not work. So that's it for that section. Just be careful with your signs when you're doing the other ones. simple graphing, y-intercept, rise over run, up 6 over 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Or if you go down 1, 2, 3, 4, 5, 6, so it's down -6, and over 1, 2, 3, 4, 5, -5. Two negatives make a positive, and that also works. Just remember that positive slope will go up and to the left, and a negative slope will go down and to the right, like this one. +3. Negative in one direction, positive in the other. Or positive in this direction, negative in this one. Same thing, draw it, and there's your negative slope down and to the left. Exponents, pretty basic. If you're multiplying the same base, then you just add the exponents. So this would be 10 plus 2 is 12, minus 6 is 8 to the 6th. Don't forget, this also means 1 over 8 to the 6th. Think about exponents as repetitive multiplication, and the negative means opposite. So the opposite of repetitive multiplication would be repetitive division. If you're raising an exponent to another power, that's when you multiply them together, because again there's going to be 5 sets of z to the 5th. So that is why. Because again, raising them to a power is repetitive multiplication, so that really means this. These two things mean the same thing, and again I use my other rule over here to get z to the 25th. Last one I'll do in this section. If you're raising a whole group of things to a power, remember each one is raised to that power. So this one would be x to the 16th, y to the 32nd, m to the 24th. How can I show that a little easier? So here, again, now there's 3 sets of 3x, or 4 sets of 3x squared. And what's happening in between the 3 and the x is multiplication. So it's all multiplication, so I can rewrite it in any order I want. So if I wanted to, I could rewrite it like this. Which is 1, 2, 3, 4, so it's x to the 8th, and then 3 to the 4th. Whatever that equals, that would be your answer. Okay, graphing. A couple things here. You could try to put this into y equals mx plus b. It's fine, it'll work. I'm going to show you an easier way. If there's any point on this x-axis, the y value is always going to be 0 because the point has not gone up and it has not gone down anywhere. Anything on this y-axis, the x value will be 0 because it has not gone up and it has not gone down anywhere. Oh, sorry, hasn't gone left and hasn't gone right anywhere. I apologize. So that point will be 0. So if I know half of the coordinate, I just need to find the other half. Now don't forget, this is the x, this is the y. So if I know y is 0 in my problem, I can just plug 0 in for y. And I get 3x. Now again, I'm looking for an exact point. So the greater than or less than at this moment does not matter. 3x equals 10. X equals 10 over 3, which is 3 1/3. So it crosses the x-axis at 3 1/3, about right there. I'm going to do the exact same thing to find another point. I know x is 0, so then I know this is going to be 0. So I get negative 2y. And again, I'm looking for an exact point, so the inequality does not matter. Equals 10. And I'm going to get y equals negative 5. Y equals negative 5. And so, in order to make a line, all I need is 2 points. I have those 2 points, and we're going to draw. Okay, now I draw the line, and then I look, oh, I made a mistake. This is just less than, so it's not a solid line, it's a dotted line. Okay, so now, which side do I shade? I always test a point. Some people could just look at it and shade. I like to test. I always try to test 0, 0. That's the easiest thing to test. So if I want to test 0, 0, that means x is 0, y is 0. So if I plug those into the equation, or inequality, I'm going to get 0 minus 0 is less than 10. 0 is less than 10. This is a true statement, which means this point works. So if this point works, everything on that side also works. Okay, I'll do this one here as well, using the same strategy. So here I know it's going to be comma 0, and here I know it's going to be 0 comma something else. Okay, put 0 in for x, that goes away. I get negative 3y equals negative 15. I get y equals 5. Boom. And then I'm going to put 0 in for y. So this goes away, and I get 5x equals negative 15. X equals negative 3. Boom. There's my line. This is greater than or equal to, so it's going to be a solid line. I'm going to test my point 0, 0. So I'm going to get 0 is less than or equal to negative 15. This is false. So that means this point is not a solution, which means nothing on this side is a solution, so all my answers are on the other side. That's how you shade, and that's how I suggest you start graphing when you see something in standard form and not y equals mx plus b. Okay. Again, pretty straightforward here. I'll just do one of them. We're solving and then putting it on the number line. I'll just do the first one. 6 minus 24n minus 28 is greater than or less than 122. Combine my terms. Negative 24n minus 22. 122. Add 22 to both sides. Get negative 24n is greater than or less than or greater than or equal to what's that, 144. Then I'm going to divide by negative 24. So now when I divide or multiply by a negative number, the inequality sign is going to flip, because remember, the negative sign in math really means the opposite. So I'm doing the opposite to everything. So I'm going to get n, flip the sign because it's the opposite. Is that negative 6? So now if I write it in this way with the letter first, the inequality sign, then the number, then I go to that number, I fill this circle in because it's equal to, and then you just shade in the direction of the arrow. All right, that's it. So this video is probably a little longer than the rest of them